Hello YouTube. Today I'm surrounded by dead motherboards. They're all from Lenovo Legions and none of them display. So we have an NMD562, another one, another NMD562, and this nice black one which is an NMD563. Today I'm going to be working on none of those. We also have this Legion here. What's different about this one is it is an Intel Legion, not an AMD Legion that I showcased in the last video. So let's see what's going on with this. It was sent in for a no power fault, I think. Maybe a no display fault. But let's take a look and see if we can get this running again. Never seem to find the charge port on these. Okay, so the RGB turns on and the power light's on. Let's leave that a moment and see what happens. Yeah, this ain't got nothing. Okay. It's looking pretty good. Looks quite clean. I think before I do anything with this laptop, I want to take it apart and give the motherboard a full inspection. Just make sure there's nothing obvious that we're missing. Oh yeah, these have these LED strips which are plugged into the back of the motherboard. Makes them quite hard to get the boards out of. Okay, let's see what's going on. Let's check some power rails. No CMOS battery in here, so it might turn on automatically. No? Okay. Do we get CPU voltage? Nope. Okay. If we don't get CPU voltage, do we get frame buffer? No, the VRAM's not getting any power. Yeah, GPU circuit's completely dead. We have RAM voltage though. Interesting. We have 5 volts underneath it. We have 3.3. I think this is another 5 volt rail. Yep, there we go. What's up here? Packs? 1V8. Okay, we have 1V8. Nothing to the CPU. Oh, we've got, that'll be one of the earlier CPU rails like VCCSA or VCCIO. Yeah, and there's the other one. But no V-core voltage and no GPU voltage. Interesting. Let's have a look at the board, see if I can see anything. Just to let you know, this board is an LA-J561P. It is from a Lenovo Legion. The model is Legion 7 15IMH05, and it was manufactured in 2020. It comes equipped with a 10th gen Core i7, and that is what's that? An N18E G2R A1, which is an 8 gig card. So I think that might be a 3080. Let me just check. Okay, I've checked. This one's a bit older. It's a RTX20xx Super, I believe, on this one. Still a great GPU. Don't really expect to find anything on the back of the board because it has that protective sticker on it. Yeah, okay, so everything looks clean, but we have missing voltages. Now we've got to ask ourselves, why would we be missing CPU core voltage? So I'm going to quickly run around some of the CPU coils and check for shorts. We've got 5 ohms there, which is probably the CPU GT core, and then 2 ohms there, and there. So these 4 are for CPU V-core, this one's for CPU graphics, and then these ones that I do get voltage on measure 22 ohms and 80 ohms, so they look good, no short circuits there. And we had RAM voltage. Well, I'm starting to think something's really wrong with this. And I've seen this before. I've seen no V-core on this model board before. This is not the first one of these that I've seen. Now I wonder if Lenovo still had shoddy soldering back in 2020. Or if that sort of started happening in 2021 and 2022. Let's see what happens. I'm going to hang the board off the desk here, so I've got access to the power button, and I'm gonna let's try and start by pushing down the CPU and recheck those voltages. Okay, I just hit the power button whilst pushing on the CPU, and no, still nothing. Okay. Let's try again pushing on the chipset. That's getting heat on the CPU now. Yep. I measure V-core. V-core seems to be coming back when I push down on the chipset. So there we go. The Lenovo Legion solder joint issue doesn't just affect AMD models. If you have an LA-J561 board, at some point you may start suffering bad joints under your chipset, leading to a no display fault. I've seen this on this board a couple of times, and I'm going to be honest, it's really difficult to fix. So just like the Ryzen video we did recently, we're going to have to rip this chipset off, reball it, and fit it. The problem with that is it also has the black epoxy. But what makes it worse is it's right next to these VRAMs. There's no real way of removing this chipset without affecting the solder under the VRAMs. So we have to remove the VRAMs as well. So I'm going to get this ready for rework. We're going to rip this chipset off. We're going to remove the VRAMs. We're going to reball it all. And we're going to hope for the best to see what happens. I'm going to quickly desolder this stud by the PCH to give me a good location for a support to go through. Okay, it's ready to go on the rework station. I'm going to do the same thing you saw me do in the last video. I'm going to try and keep the preheat and the bottom heater as low as I possibly can on this profile. I don't want to heat up the GPU too much. I don't want to heat up the CPU too much. The heat must be, as best we can, focused around this chipset. Now, should I shield these VRAMs? No, I don't think it makes a difference. I've done this job before, and these VRAMs always pop a proper solder joint after reworking this chipset. They're just too close. So I'm gonna get this chipset off and just assume that these VRAMs won't handle the heat and will also need to be reballed. Same as before, we're going to use an underfill blade to get in and check that the solder's molten, and then we're going to lift it up at the corners and try and get that PCH off cleanly. Okay, so time to rip this PCH off. Okay, we got the chipset off. I think it went okay. Took me a couple goes to get it pulled off. The epoxy was kind of difficult to overcome, but we got there in the end. Let's get the board cleaned up. I'm gonna check it on this iPhone screen separator, which I quite often use as a PCB preheater. Just let that heat up a bit so it's a bit easier to clean. It looks okay. I don't see any damaged mask or any ripped pads. Cool, yeah, that looks like it went very well. Okay, I almost forgot about having to do the VRAM for a second there. So let's remove the VRAM and then we can fit the new chipset. Okay, so we have the board prepped, ready for the chipset to go back on. And if that works, if the board power's on, we'll put some VRAM back on it and get the system finished off. Okay, we have the PCH back on, and we've got the VRAM back on. So let's get this put back in its casing and see what happens. Right, the moment of truth. Will it work?
Nice.
Okay, well, as you can see, the system is working again. And there we go. Another Lenovo Legion that narrowly avoided e-waste, fixed by resoldering some bad joints under a BGA chip. So that's all for this video. Big shout out to Lenovo for single-handedly keeping me in business. If you haven't seen my other Lenovo Legion video already, you should go check that out. So with that, I'm going to say thank you for watching. If you like this video, give me a thumbs up. And subscribe if you want to see me inevitably reball more Lenovos. Goodbye.